Welcome to the first video of Chapter 9. Thanks for watching it. So we have talked about derivatives and we've just barely reintroduced series. It shouldn't surprise you that the second part of section 9.1 is combining derivatives with series. So here we have a problem. Find a power series for 1 over 1 minus x squared. Now there may be some tricky ways for you to do this using the techniques that we already know, but what we're going to do in this example is focus on how we can use derivatives to be able to find this power series. So using what I know about derivatives, I know that if I took 1 over 1 minus x, and if I took the derivative of this, let's slide over a little bit, the derivative of this guy, then that will end up giving me, let's see, we could do a little bit of math. I'm going to do it on the next page. I don't clutter this page up. So this is the same thing as 1 minus x to the negative 1, and doing the chain rule, the derivative of the outside would be negative 1 times 1 minus x to the negative 2, and the derivative of the inside is negative 1. So that simplifies to give us 1 minus x to the negative 2. So, going back here, the derivative of this is equal to 1 over 1 minus x squared. So this can become really helpful. So if I can take and find a power series for this one, then I can take the derivative of that power series, and that will give me the power series for this one. So let's go ahead and do that. So I'm going to slide this one down. Okay. So the power series of 1 over 1 minus x. So that is equal to, let's do purple. This is going to be equal to, well, we've already done this power series, right? It's a is 1, r is x. So this is a pretty simple one. A plus ax plus ax squared, etc., etc. Or we could rewrite this as the summation of n equals 1 to infinity of ax to the n minus 1. Alright? So if I took the derivative of it, slide this back up because now we're taking the derivative. Okay, so we're going to take the derivative of 1 minus x, and I'll take the derivative of each of these terms. I'll take the derivative of a, the derivative of a being 1. I don't know why I didn't put a 1 in there. You probably were wondering, why didn't you put a 1 in there, Mr. Luke? Well, I don't know why. Let's erase them. I put the x in. Should have put a 1 in for each of these a's. Or leave them out altogether would probably be the better way of doing it. Okay, so 1 plus x squared. That's the power series. So the derivative of 1 is 0. And then the derivative of x would be 1. The derivative of the next one would be 2x. And then let's throw in the third one just for fun. 3x squared. Okay. So we have it's equal to 3x squared. So the summation, if I took the derivative of the summation, we would end up getting the summation of, for n equals 1 to infinity, and then we would have, I'm going to run out of space here. Let's slide it down to there. So just doing the power rule on it, we get n minus 1, because that's what the exponent is, times x to the n minus 2. Because now we're subtracting 2 off the exponent. And we can see that this purple formula works because when I let n equal 1, 1 minus 1 is 0, 0 times x to the negative 2 is going to be 0. Okay, so this does end up working for each of these values right here. So this part are two different ways that I could write the power series. Oftentimes, in math books and other things, they notice that since the first term is 0, I don't necessarily need to include it. And so instead of starting when n equals 1, they will start the summation when n equals 2. When n equals 2. Because the first term is just 0. That's the reason why. But I mean, it's not incorrect what we had first, but this is just maybe a little more logical. Success! We did it! By taking the derivative of a power series, we were able to find another power series, namely 1 over 1 minus x squared. And so when you come to class on Tuesday, we are going to be doing a lot more of these, taking the derivatives and taking the integrals of different series to find other ones. And that becomes a very helpful tool we'll be using in the next few sections. Because you are all such eager beavers, here is the assignment if you want to start working on it, at least the part that we have covered in class. So page 481, problems 1 through 14. So there you go. Hopefully this will help the lesson go a little quicker and make a little more sense as we learn it. Have a great day. Adios, muchachos.